Okay, so for the demo, I'm going to break this into two parts. I'm going to go over the code real quick, and then I'll show you some video of the rest of the demo. So this project is split into a few different folders. We have the source folder, the config folder, and then like the main file. These other folders are just either some scripts that I wrote for the demo or random other stuff generated by VS Code. So anyway, we could start with the main function. This is like the main entry point for the program. I have some task includes here, a reference to the PubSub client, some init steps, our setup, and our main task. This just makes sure that the MQTT client is maintained on the server. So that's that. The source folder is a location where all of the tasks are defined. So all the tasks are defined in one single location, which makes it easier for development. So for instance, I have a few files here for different kind of tasks. So I have tasks defined in each of these. And they're all in this source directory. Also in this source directory, I have this taskinfo.cpp file. So this is where all of the tasks are defined in these structures. So in FreeRTOS, you have to define all these types of parameters for a task. And then this is how you schedule a task. So if we look at the task info definition, you need all these fields. So an entry function, a name for the task stack size, any parameters you want to pass in the task, a priority, a handle, and an enum. These are all used by the FreeRTOS scheduler. So all of the tasks that you would ever want to define would be defined in this structure. And then depending on what board configuration you want to use would impact which tasks are actually scheduled. Or yeah, so for example, this is the board config.h file. Here you could choose which configuration you want to use. So for instance, if we uncomment board 1, this is the configuration which will be loaded onto a board after compiling. So for instance, we have all these things set, and then here is where we choose which tasks to include. So if we set it to 0, they're not included. If it's a 1, it's included. And these are stored in this little static array. So going back to taskinfo.cpp, we have a function called register tasks. And here we grab that static array and then loop through them to see if they should be scheduled. And if they are, a task is created with the information up here for the task. And then it is created and put in the scheduler's queue. Going back to the main function, in FreeRTOS, or at least for ESP boards, there is an implicit call of the task start scheduler. Oops. And this function is just scheduling all of the tasks that you created. So since it's implicit on the ESP, I don't have to call it, but it's happening somewhere before the loop function's called. But yeah, this is the program structure. Cool, so this is the second part of the demo. I'm going to show you a basic application I made that's just using MQTT in this real-time environment. So first, a little overview of the hardware. I have 3 ESP32S2 boards. The 2 in the back have a button attached to each of them right here. This board in the front has a temperature sensor attached to it. So let's start the server. So this is starting the broker, and instantly we could see that device 1, device 2, device 3 are on the server or on the network already. So that's going. I'm going to start up the Python script I made. That's just also a client subscribing to all the topics. And as we can see, the temp data is showing on the GUI. I could also show the buttons being triggered. So left button, we could see that event happen here, and then its corresponding count updates. I could press the right button, its event topic is posted on the broker, and its corresponding count also updates. So I could do that left, right. Here are the two events, and then they get updated here. So basic example of the MQTT network in a real-time environment. I could show how easy it is to program a new board or to add a new board to the network. So let's say I want to reprogram a board. For this case, I'm just going to change the name of it. Let me disconnect the other two boards. We don't want those connected as we're programming. So we have the board name changed. I'm going to quickly upload it. Cool, so now it's done uploading. And what we should be able to see is the device name changed. It should start saying 9, and right here on the broker we see that the device 9 is showing right here. So it's very easy to reprogram boards, meaning it's really easy to add new boards to the network. It's also easy to remove boards. We can just turn them off. So since I removed the other two boards, they're no longer showing on the broker. I just reconnected them, and they're showing again. Oops, not yet. Oh, yeah, device 2, device 3. So very easy to scale this network. And yeah, this is the demo.